In the last videos, I request you to work on this exercise to compute the percentage of within individual variance on surface acting, anticipative deep acting, and situational deep acting. And now we are going to discuss the result. First, you have to open the file and then click on Analyze, Compare Means, and One-Way ANOVA because we have to get the index from the ANOVA table. Then put all the variables under the dependent list and we put the ID under the factor box because we want to see the within persons variation. On the right-hand side, we click on Option, and then we click on the boxes of descriptive, homogeneity of variance test, Brown, Forsyth, and also Welch. From the ANOVA table, we can have both the between group as well as the within group sum of squares for these three variables. For the surface acting, when we are calculating the within individual variance, we have to use the equation of within group sum of square divided by the sample size. As I said, that is the 420 observation in our case. And then we find it 0.59 for within individual variance on surface acting. Between individual variance, we also use the index, and we find that is 0.4. For the percentage of variance within the individuals, and we also find there is a 59.59%. Anticipative deep acting, and I'm not going to repeat it, but as you can see that we're also getting the number from the ANOVA table and follow the equation. And we find that the percentage of variance within individual is 36.98. Situation deep acting, again, we followed the equation and we find that there is 60.20%. For these three equations, we found that the percentage from the analysis, we can see that the daily surface acting, anticipative deep acting, and situational deep acting display considerable variance at the date level. And so, well, usually it's higher than 30%, and we will consider that it is appropriate to utilize within person modeling for data analysis. Of course, the higher probably is better because it shows that there's more variation within the person. Let's proceed to work on the SPSS mixed model. That is the multi-level data analysis. And here is the research model. We would like to investigate whether the individual daily surface acting will affecting the daily exhaustion level as well as the daily performance level. They are at the level 1, the daily level. And we are also interested to see whether the individual level of job control, that is the level 2, will also make a difference on this relationship. For this setting, and we have to use the SPSS mixed model, the multi-level analysis to perform the hypothesis testings. We are assuming that we have already performed ANOVA test and calculate the between person and within person variation, and finally to calculate the percentage of the within persons variation. And we are assuming that all the data will have appropriate to use the daily level analysis to have a higher percentage of the within person variation. We are assuming that we have already performed this analysis. So now we have to move on to how we are going to test this research model by using SPSS mixed model. Because the current model consists of the moderation effect, that is the job control is the moderator, Before we perform the SPSS mixed model analysis, we have to calculate the standardized value for all the variables. What we have to do is, we have to click on the Analyze, Descriptive Statistics, and Descriptive. We have to put all the variables that you want to generate, their standardized values, under the variable box, which including surface acting, job control, exhaustion, and performance in these studies. And on the left-hand side, we click on Save Standardized Value as Variable, and then click OK. And so all the standardized values of this variable will be created at the end of the data sets. And then we can perform the mixed model in SPSS. And please watch the next videos to work on the steps on mixed model in SPSS.